In 2023, a single vulnerability in a bank's online platform allowed attackers to siphon $42 million from a customer's account without triggering any single alarm. The security team saw green across their dashboards, no intrusion alerts, no failed logins, no suspicious activity flags. Meanwhile, in a European data center they will never hear of, automated scripts were quietly moving millions through cryptocurrency tumblers. What if I told you that most online banking platforms today still contain the exact same vulnerabilities that allowed the 42 million haste? Welcome to another ethical hacking project with Great X Labs. This isn't a theoretical exercise. This is a secure bank, a production-grade banking platform we have built for this demonstration. It has beautiful animation, responsive design, and enterprise-grade, and every critical vulnerability that real banks spend millions trying to patch. Let's get in. In our connected world, security is about protecting real people and their lives. First, meet John. Over the past 6 years, he's diligently saved $28,000 for his daughter's college fund. His vulnerability, an attack called session hijacking. This is Jane. She runs a small bakery, managing $65,000 in operating capital to pay suppliers and her staff. Her point of exposure, cross-site request forgery. And here we have Mark, a bank administrator with high-level access to the entire banking system. The threat he faces, a classic but devastating SQL injection. Now watch closely as we move forward. Over the next hour, you will see how a single attack can compromise John, Jane, and Mark using these specific techniques to bypass even modern security systems. We will begin with a rapid-fire look at the mechanics, exploiting unvalidated API endpoints, intercepting and altering network traffic, injecting malicious database queries, and hijacking active user sessions. These 4 attack vectors form the basis of 87% of modern banking breaches, according to the FS ISAC of 2024 threat report. Our attacker begins by targeting John through the most common banking interface, the web application. The attacker doesn't target John directly. Instead, they target the login page that all users share. They input a classic SQL injection payload in the username field. As you can see on my screen, this is the login form. So the attacker writes something like this: single quote or in capital letter space single quote 1 single quote equal to single quote 1 single quote with 2 hyphens to comment anything that comes after. These 2 hyphens will ignore the next box, which is the password. Let's hit enter and see what happens. If you look at my screen now, after using the SQL code, we got an error that says invalid username or password. And you might be asking why I had to write a password after I told you 2 hyphens would comment everything that comes after. Now, the form has been set to receive username and password. So once you use a classic SQL code like this in a form, you can write anything in the password. For me, I just wrote dummy, right? That was not the password. I didn't have any password. Remember, the attacker has no password, but he wants to attack John. And after trying our first classic code, it failed with an invalid username or password. But this makes us understand that there's actually a database with a username and a password. And if you look at the URL at the top, we have the extension with a 1 at the end, showing that there's a database table and we are working on the first database table. So let's go ahead and run our second command to see if we can bypass this. Next, the attacker will try some common classic injection codes again. Like let's try admin single quote double hyphen, and you see we have the same error. It still says invalid username or password. Remember, the system checks the username before the password, so at this point it is the username that is failing. And we try something again. We can try admin with single quote only. We can try admin single quote backward slash with a star, and let's try this last one, single quote or in capital letters single quote 1 single quote equal to single quote 1 single quote or space single quote 1 single quote equal to single quote 1 and hit enter. This is one of the strongest classic code we could use, and you see we still have the same error, right? So now we need to use a different attack method. Let's try to enumerate the users. First, I'll just head back to the attacker's machine. You can see my Kali Linux terminal, and I will create a file as enumerate_users.py. I'll nano into that file and paste this script. You have the script on GitHub as well. After that, I will just save and exit. Let's try to run the script and see the result we get. After I saved the script as enumerate user.py And since I'm using Python, I had to run the script, and you can see here it started enumeration and some users have been seen. You can see we have 4 users existing, but our 3 users we are targeting, we have them up here. They are real account numbers, the users. We have administrator, the customer, and the business owner, right? So we have enumerated and we got the usernames for the 3 users that we have active in our web application. Let's move to the next step. Now that we have the usernames of all our users, you see we have used just one attack method to get the 3 usernames of the users we are attacking in this web application, which is Jane, John, and the administrator. Now we need passwords to this account. That is why we need to introduce brute forcing. I'm going to show you 2 methods to brute force here. We are going to use a terminal method, that's a matrix terminal method. This is more of a futuristic scan now. And we are going to use another one that will show us like an actual pop-up windows. So you can use any of these. I'm going to leave this code in my GitHub repo. So for those who want to put this into practice, you can use any of these. Those who like working with the terminal, you can just use the matrix style, which is option 1. And for those who like working with an actual graphical user interface, you can go with option 2. But note, either options you're using, we are doing the same thing. We have gotten our username and now we want to brute force using our password.txt list. But here we are not using a password.txt, rather we are running a script. We are running a Python script. You could still use a password file like rocku.txt or create your own password.txt file. But in this particular tutorial, we are running a Python script to brute force since we have the usernames already. Now that we have our 2 files ready, the graphical user interface and the terminal version, we are going to start with option 1, which is the terminal version, by running this command. Just run this command on your screen. Python, name of the file. I named the file quantum_terminal.py. So I will run Python quantum_terminal.py and hit enter. You can see it initializing attack, and we have gotten the first name already, cracked John Doe with the password. The second name, cracked admin with the password, and we've got the third name, Jane, cracked with the password, highlighted in green. So you see, just with brute forcing, just in few seconds, we have already gotten 3 users, and that's the users we are targeting, right? With just a single attack. Initially, we had to go with 4 attacks to get these users, but now just with brute forcing and enumeration from users, we were able to get their credentials. Let's try to log in and see if these credentials work. Let me copy for John. I copy the username. I'll just paste it here, and I go with the password and I paste it here. Remember, this is the attacker. The attacker does not know the username and password of any of these users. He just used trick and attacker mindset to get this by enumerating users and using a password script to crack the password. Now, if I click on login, you see we have accessed John's account without having his password initially, but now we are into his account. You can see all his details here. The same thing that will happen if you log in with admin and if you log in with Jane. This is how easy an attacker can use just one method to be able to access millions of users, and from here they will be able to transfer money to any other account they want, do whatever they want, because they have accessed the account like the actual user. For those who want to use the terminal, you follow the same step we just used now. You're going to succeed with your attack. But for those who will be comfortable using the graphical user interface, I built a very small tool, a window that will pop up once you run the script. This window will pop up and you will have to start the attack to see what is happening from the graphical point of view. Now, if you run this script, quantum_gui.py, it's going to pop up what you're seeing on your screen. You can just click on start attack. At the top, you can see we have testing 30 passwords against 6 accounts, right? Because we enumerated 6 users and we had 3 active users out of those 6. Now we have created a very small password.txt script, or we can also use password.txt file to run this brute force. But in this tutorial, I'm trying to run it at the intermediary state, so I'm using a Python script. And here, this tool, once I click on start attack, is going to automatically start attacking using the same method the terminal used. So let me click on start attack here. You see it's attacking. We have 35, going very fast. We have cracked 6 username, right? And we are looking for 6 passwords to match those usernames. But we know for sure that we are going to get 3 because only 3 accounts were active. Now they say attack complete. Attempt 222 and cracked 3 passwords out of 6. Now we are good to go. Let's see the password that was cracked. You see it's the same thing. You can still use this to log in as we did with the terminal version. So this is how easy it is for an attacker to target your system, target your web application, and use just one attack method to be able to compromise multiple accounts. In conclusion, this project successfully achieves its core objective to demonstrate how seemingly minor security flaws can be chained together to create a critical breach. We moved beyond theoretical concept and built a functional lab to prove that weak authentication mechanisms present a tangible, immediate risk. Our intention was clear from the start: to dissect a realistic attack chain from initial reconnaissance to financial impact within a controlled banking application environment. We aimed to make the abstract threat of hacking concrete by showing each step an attacker would take, the tools they would use, and the devastating result they could achieve in a shockingly short time. Here is how we achieved it. We started with reconnaissance, creating a Python script that exploited error messages to enumerate valid users like admin, John Doe, and Jane Smith. This proved how information leakage is the attacker's first foothold. We engineered the core breach by developing an advanced brute force simulator, our tool featuring both a terminal-based and a GUI interface. GUI stands for Graphical User Interface. Systematically tested dozens of common passwords, successfully cracking weak credentials like admin123, we had password123, and another password because we were able to capture 3 users, right? And it was highlighted in green in our tutorial. All these codes are available in my GitHub repository. You can take it to try this again. And thirdly, most commonly, we demonstrated the consequences. We didn't stop at just logging in. We scripted scenarios showing unauthorized fraud transfers and sessions hijacking, qualifying a total potential theft of $45,000 to illustrate that a breach passwords leads directly to financial loss and loss of trust. The success of this project is not in the attack itself, but in the clarity of the lesson it provides. We have proven that without a defense in-depth strategy, systems are vulnerable. The path to protection is clear. Eliminate information leaks with generic error messages. Defeat brute force attack with rate limiting and account lockouts. Nullify stolen credentials with mandatory multi-factor authentication. Secure the session using HTTP only and secure cookies. Guard critical actions with CSRF tokens and transaction monitoring. This project serves as a powerful case study. It shows that the security is not a feature to be added later, but a fundamental principle that must be designed into the layer of an application. By understanding and demonstrating these attack vectors, we are better equipped to build and advocate of the resilient system that our digital world depends on.